isn't it? My
Okay.
my my
I
calendar has both of them.
I did go to the post office and they were closed today. So anyway, welcome to the October 15th, 2024 session of Tapper and HamSCI technical session. My name is Dave, KB0S, and this week I have been um, rebuilding my 3D printers. So that's taken a bit of my time. I can only work on it a couple hours at a time. So uh, it takes a while to get through it all. Anyway, next on the list, we have Gary, AF8A. Go ahead, Gary.
Yeah, thank you, Dave. Good evening, everyone. I've been poking around trying to finish up the solar eclipse QSO party. Thought I was done on Sunday, and then I did some quality checks, and I found some people's logs who claimed they were both single operator and multi-operator in the same log, which is, of course, impossible. So I'm trying to reach out to those people. But my only advice is if anybody is a contester and you send in a log, please open your log and take a look at the header before you submit it, because a lot of this could have been avoided. But anyhow, such is the life of a contest manager. But it's fun. Anyhow, back to net.
Okay. Next on the list is Dave, KD0EAG. Go ahead.
Um, Not a lot of excitement here. Um, Let me think, what have I been doing? I'm not sure. But I did get some of these little antennas to play with from China today. I've um, still been labeling things. There's no end of things to label, and never ends. But that's about it for me.
Okay. Next on the list is David, N1HAC. Go ahead, David.
Good evening, everyone. I've been playing with antennas and preamps this week, working on specifically a rheometer project for our what we're calling the cinema movie project, which does have a HamSCI component. And rheometer is used to detect solar flares and electron precipitation by measuring the D layer absorption. So it's a noise measuring system in the 30 to 50 megahertz range. So I'm looking at antennas. I've got a reference antenna beam, 3-element beam pointing straight up, and a reference receiver, which is a lot more complicated than what I think we need to do with modern technology. And then comparing it to loops and E-field antennas and such. I've got number of the instances of that LZ1AQ either running or coming. I have the actual LZ1AQ coming, but it's coming from Bulgaria. I have a supposedly lower noise version that was done by N4CY. And I have the one that I got from Ella Kits and Parts when I bought the RX888 from them a little while ago. That one is actually being used currently on my Grape 2. And I also have a splitter that I use to sample that to compare. They all seem to be doing reasonably well. Of course, my 40-meter horizontal loop does the best, but those are doing fairly well. I should have an E-field reference antenna, but I think it's got a bad front end, which I need to replace. It's a very similar design to the one that Rob just sent the presentation on. And I did read the article. We'll, I'm sure, discuss it further. But one thing I noticed is it points out that it's not necessarily the best receive antenna, but it is a reference antenna. It's not a bad antenna, but a dipole or a E-field dipole or a loop might be a better receive antenna. So that will be part of our evaluation, I presume. I think that's about it. Back to Net.
Yep. I did want to mention, during last week, I did get an email from Bill Engelke, and it had a copy of, I believe it was either Wednesday or Thursday's flare from my magnetometer. And so apparently my magnetometer is still working.
Oh yeah, and then there was the geomagnetic storm. Did get to
Yes.
see a little bit of it, but it was mostly cloudy here and found some sucker holes.
Well, it was
That
a,
was
a
pretty
nice bump
spectacular.
on the magnetometer. So
Yes, indeed.
So next on the list is Andrew. He's on the phone, it says.
Hi.
Andrew, go ahead.
I'm new to the Google group. I've been paying attention for a couple of years to HamSCI through the Zoom conferences. Wasn't able to make the in-person gathering this year, but was interested in learning more and I don't know, maybe at some point participating a bit in the TAPR work. So I figured I'd drop in. Thank you for having me.
Well, welcome. And if you find it interesting, please come back.
Thank you.
Yes, next on the list is Bob in 5BRG. Go ahead, Bob.
Hello, folks. Spending a lot of my time still working my meteor camera issues here, and that's been my main focus anyway. So back to you, Dave.
Okay. Next on the list is Dave H, W6OQ.
Okay, good evening. Yeah, the last 2 weeks I've been recovering from back surgery. I'm not there completely yet, but and it took longer than I thought it was going to. But anyway, I caught up on the last two of these meetings on the YouTube recording, so I'm up to speed there. And you know, looking at what's going on for in the antenna group and the discussions and stuff there. And I think people are starting to engage there, and I'm here to do that.
Yep. And just a reminder to everybody that HamSCI records the YouTube, or makes recordings of these meetings and puts them on their website on YouTube. A YouTube link on their website, sorry. Next on the list is Dave Julian, WB9YIG.
You got it. You got it.
I got it in the end.
Yeah. Good evening, folks. Not much going on over here. Just trying to get about 500 pounds of E-strap put together. So I'll just learn on the antennas tonight. Back to the net.
Very good. Next on the list is, Jamal. He's asleep up there, I think. It's like early in the morning for him. So
yeah,
welcome.
yeah. Hello, Dr. Dave.
Yes.
Good morning, everyone. It's 2 a.m. TAPR meeting. Yeah, but it really worth to be within the HamSCI family. Yeah, I'm really glad that the research for Dr. Nathaniel and I has been accepted to be presented at the European Space Weather. And I'm really glad that I had a couple of days before feedback from Dr. David McGow. And I would really like to thank you, Dr. David, for your feedback. I've been working on it, specifically on the antenna's performance and the sizing and etc. Actually, I've been working on the presentation involving the utilization of the HamSCI network, the hardware components, specifically the transmitting beacons to be used for further localization. Also, I am now working on using FarLab, which is MATLAB based, in order
Right.
to calculate the received power. So I would really glad to have any feedback from anyone here about. I'm still doing my best at this point how to get the powers from Far Lab. Yeah, and I hope it works. Thank you so much.
Very good. We're always happy
Yeah.
to have you here, even though it's the middle of the night.
Yeah.
Let's see. Next on the list is Jonathan, KC3EEY. Go ahead, Jonathan.
Hi, everybody. Um, uh, not too much going on. This week, I was kind of busy with non-VLF matters, but not this Thursday, but the previous Monday when we had some geomagnetic activity and some aurora here in northeastern Pennsylvania. That morning, I recorded some weak dawn chorus. It was about an hour and a half dawn chorus event. Sounded really beautiful. I'm in the process of pulling the recording. Just have to find the start and stop. That's always the time consuming part, because what you have to do is you have to pull a chunk of recording, and then you kind of have to manually go through and listen for when it actually started and when it actually stopped, and then once you know that the times, you could just pull the whole recording, and then you have that for your a record. The Thursday night geomagnetic storm only seemed to produce a bunch of risers, but didn't seem to produce a dawn chorus event, at least not a strong one anyway. The detector can't always detect a dawn chorus really well, especially diffuse chorus, which is definitely pretty possible. So as far as hardware, I'm thinking about the final design, the useful design of the GPS interface. So the GPS interface has to produce a pulse per second output for the sound card and the serial port of the computer. I was thinking of using a one shot to produce, or well, a monostable circuit to produce a fixed pulse width from any pulse width that's set on the GPS receiver. And then I'm also thinking about how to design a circuit, also using some monostable multivibrators for transmit and receive indication on the serial lines. Now it's actually not as easy as you would think, because data, especially at 9600 baud and 115 200 baud, it's obviously the pulses are much too quick for perception. So you would want to lengthen those pulses. So the trick is to lengthen them in a way that it's actually perceivable that there's data going back and forth. I'm looking to achieve something similar to what you would see on an Ethernet switch for both the transmit and the receive. So I believe that should be an adequate box or a and adequate interface for the GPS, which I'm going to make for this project, but also it'll be an in general GPS interface for VLF purposes, which could be used with both VLFRX tools and people who use Windows with Spectrum Lab. So it could be used with both. It'll be kind of dual purpose, and it'll be, and the point is to have it already built, have something people could buy just to get started, to get them into VLF a lot quicker without having to roll their own hardware. So that's the idea behind it. Lastly, the Lenovo, there was a Lenovo thin client PC that was in one of Nathaniel's presentations. Rob, did you happen to suggest to Nathaniel that thin client for the RX-888?
Yes, that's I'm responsible for that. It's not a Lenovo. Oh, you can use a Lenovo, but if you're going to buy something, if you're going to invest your time, you're better off to invest in a B-Link brand mini PC. It has 4 times the computational power at twice the price, and that's a good trade-off for the whisper reception and recording, grape recordings. So, if you want to know more, I describe it on the Whisper Demon GitHub page. There's a wiki tab there, and I describe a bunch of things about setting up Whisper Demon and B-Links and other things.
Okay. All right. Yeah. Because that was it was a Lenovo ThinkCentre M910Q, something like that. It was, but it was one of those IBM thin clients, and it seems to be a competitor to the Dell thin clients that I'm using for the VLF system, and I felt that was a really good option, as another option for a thin client PC. It has an option for a serial port. I think most sold on eBay come with a VGA port installed. You could take that out and put a little daughter board in there. But I wanted to. Oh, go ahead.
Yeah, we don't. Okay, that's not something that we've needed to use. But I just caution everyone, if you're buying, I think the ones we've been using come from the refurbished markets, and you want to be, these things are 5 and 6 and 7 years old, so you want to be sure that if you get one, that you get one that at least has the i5 6500T 6th generation Intel processor. The earlier CPUs are problematic, but you would need to look at it and see if it had the adapter. Some of them, I've had some with VGA come from the refurb. They include VGA cards. I think you can put in a mini PCI or something. They will fit into the. But you can get them for like $90 refurbished from Amazon or eBay.
Okay, all right. Yeah, thanks. Yeah, I'm gonna get one and I'm gonna give it a try just as an alternate because it could probably run VLFRX tools pretty well and work well with VLF. And seeing that, I just thought that it was a definitely really good option. So thank you for that, Rob.
Yeah.
I'll look at your resources soon. That's all I have. Back to the net.
Okay. Next on the list is Michael Howen. Go ahead, AC0G.
Yeah, good evening, everybody. I have, as part of trying to support the DAISY grant and picking a standard antenna, I've installed DX Engineering antenna, the nominal antenna that Nathaniel included in the grant, and so that's up and running. If you look on the Grafana pages for Whisper Demon, it's listed as AC0G/FB. That's Foxtrot Baker. I've also, Dave, thank you for the reference to the fella in Maine. I can't remember his call sign, but I got one of his LZ1AQ knockoffs and have installed it with a copper um, 1.25 inch pipe hexagonal loop that's about 3.5 feet in diameter on the ground, and it's functioning and posting spots as AC0G/B1. So anyway, those are two antennas. One is a loop antenna, low impedance, low noise amplifier at the antenna. The other is a high impedance monopole spiked into the ground with an 8-inch ground rod antenna, producing some whisper and grape results, and currently being posted. Of the two, my preliminary impression is that the DX Engineering antenna, it performs quite well. It's a bit noisier. The noise floor is a little bit higher. The noise floor on the loop is a little bit lower, but these are just preliminary results. They have a very, very similar, in fact, identical set of inline components that include a medium wave notch, Paul Elliott's Turn Island shelving filter, and a DC blocking transformer before they hit the receivers. Both of them also have just a T junction, and the signal is split between the 888 and a Kiwi that Rob, Rob's kindly sent me two Kiwis, one that I can use with each of these antennas. So I can use the superior web interface that the Kiwi affords to look at what's happening with the spectrum. Hopefully we'll, on this basis, start to get some decent information we can use to make a final recommendation to Nathaniel about what to include in the distributed packages that are going to be used in a DAISY grant. I'm sure Rob will talk a little bit more about the possibility of an antenna that may originate in Europe in the ENAMS project there, which has the advantage of being a kind of standardized antenna as part of their noise measuring project in Europe. If it works sufficiently well as a receive antenna for our DAISY purposes, it may be useful to incorporate because of the double duty it can do in integrating the noise measurement efforts in Europe with with the deployments that we're using in the States. Anything else here? No. I'm trying to chase down noise, local noise, the perennial problem. Back to Nat.
Okay, well, I'm going to mention Scott Newell, who said he has no mic, but he has been commenting in the chat session. And next we have Robinette. Go ahead.
Okay, well, I can talk about it. I'll talk about antennas because that can go on forever. But my major activities this last week have been getting ready and going out to KPH, where I'm a volunteer. This is a historic amateur radio, commercial maritime radio site north of San Francisco, established by Marconi and Dr. Beveridge back in the teens and 20s. And upgrading that site. There are last month they deployed finally reinstalled the Marconi T antenna, which is it's out in this marshland area, very remote. So it's, I believe, the quietest received site on the West Coast. The T itself is about 70 feet vertical. The horizontal run, it's asymmetric T, so one half is about 400 feet and the other is 150 feet. So there's a 600-foot long horizontal element to the T. And this is, I confess I was a little skeptical about the value of them they cost the Park Service $100,000 to install this, much of which was involved clearing the marshland and gaining access to where the telephone poles are planted. But if you I'm going to share briefly and show you what it looks like. Hold on, this is the top spotter. So let's see, can I get access to this? Here's Kiwi 72. Whoops, I have to, it timed out while I was out. This is a Kiwi attached to that. I may have to turn off the sound. No, it's off. This is that Marconi T. We're looking at the full spectrum from 0 to 30 megahertz. What I did was I've added a AM band blocking filter because there's a National Park Service transmitter. If you go visit a park, they have those little AM broadcast transmitters. Well, this is the let's see. Hold on a second. I can't get. Let me zoom in on that. This is what the Park Service transmitter looks like at 1610. Not only is it really strong, but they grossly overmodulate it. But it's not really a big deal as long as it doesn't overload the Kiwi, which now it does not. But if you look at this shows you between the AM broadcast channels here, you can see how quiet the AM broadcast band is. I mean, this is the background noise level out there. So interestingly, this T and the componentry do very well going down to LF frequencies. This is 20 kilohertz. So we're looking at the this transmitter is the NTL in Australia. There's a submarine transmitting site. This is this one is let's see. The one at 25 kilohertz, I think it didn't show up. It's Jack Creek. It's I think the most powerful transmitter in the world, 2 megawatt, 22.5 or something megawatt at 22 kilohertz. But anyway, so this site is now these Kiwis are not getting overloaded by the signals, and they have a RX 888 Whisper Demon on each of them individually. So each antenna has its own 888 and I'm not yet reporting separately. I'm only reporting from the other receiver, which is attached to a shortwave antenna, the TCI 530. But these, this has taken me years to really get this this level. But if you look at this thing, this is what a good clean RF spectrum looks like with not a lot of background noise. You can kind of see the resonances of the T here. There's where there's a match at certain frequencies, and in here, this is where there's that you're out of resonance with the T. There's no matching with the T. It's just connected directly to a RG8 that comes in to the receiver. Anyway, that was this site is now up and available to anybody who wants to listen. And we have we have this antenna which you can listen to up to 30 megahertz, but of course it's not an optimal antenna for that frequency. The second antenna, these are at kphsdr.com. You can get to them. And let's see, 73. Yeah, this is what a quiet. Oops, I need to put in my call sign. This is what a quiet high frequencies. This has a AM blocking filter, so it doesn't see anything below. But this is what a quiet, truly quiet receive site looks like. There's almost no buildings or power lines or anything within miles. So it's anyway. That was my major hardware activity for the last week. As you saw, I did forward to the group this. I've been working with Michael Harjay about deploying a one of our ARX 888s and a whisper sound down at the German Antarctic Research Station. Michael's going to take it down there in January and install it. They have been on air. They do have transmitters and they do have whisper reporters using red pitayas down there. But this will allow them to have 888, so we'll be getting many more reports and more calibrated reports from them than we've been getting, and we can get from their red pitaya systems. So if WWV reaches the Antarctic, we will have some recordings from them. So and in the process, I learned, working with Michael, I learned that he was the designer of this antenna system, this reference antenna for the German radio club's ENAM systems. And the ENAM systems is a project, I think, in collaboration with the German Radio Authority, and they wanted to kind of revisit the whole effort to identify what you can expect in terms of background noise level across the radio spectrum. There's an ITU spec that was developed back in the, I think, 60s or early 70s that is still the kind of reference for what good, clean, and quiet radio noise levels should be across the spectrum. And that background noise level, which is there's a document in the document that I sent out, there is a reproduction of that ITU level. The goal of a good receive system would be to have the antenna system do better, contribute less noise than the ionospheric propagation does at all frequencies. And that's not, it becomes very much not a trivial problem when you get up above 10 megahertz. And you can read, I think Michael's professor, of electrical engineering, University of Bremen, and I think he's pretty well versed in the antenna technologies and went through the theory of antenna reception efficiency in some of the pages of his presentation. So the conclusion was that, of course, the three antenna types you'd consider, active vertical, like with radials, active horizontal dipole and monopole. Each have their own and loop. I'm sorry, I think he really considers the loop, the loop antenna. Each of them has their benefits but his conclusion was for their purposes to best measure the background noise level across the full spectrum, this active vertical antenna provided the best basis for making their measurements. And if you think about it, of course, if the antenna is contributing, and the amplifier especially is contributing less noise than is being received from the antenna, then basically you're getting every signal that you can. That you can't, given the only way to do better than that is to have a directional antenna. But for an omnidirectional antenna, you're almost have to pick a vertical. Now, so he has a design there, and there's a schematic and pictures of the antenna, the active componentry at the base of the vertical member, and the schematic is there. What he doesn't have is they made a bunch of them, but they don't have any more. They're not commercially available. So if we want to even test it, I think we're going to have to construct one. It seems like a lot of trouble. There is someone who occasionally, I understand there are 2 of those antennas installed here in the US. Most of them are in Germany. And Michael said in our discussions that they are eager to extend the sites contributing to their network. And they have a database that presents the noise data, level data, much as our personal weather station database presents our WWV spectrograms and so on. So it would be being able to contribute to their servers would seem to me to be a great complement to the other measurements that we'd be doing. And we could extract the information as another service running on the Whisper Demon on the B-Link host. There's plenty of CPU, and in fact, talking with Phil Karn, who can't join us tonight, I've been chatting with him, and he's already extracting the noise level data, so it's already available. I mean, you can run a program called Power that comes as part of this package and get the bin data from across the whole spectrum. I think Phil might need to modify it to he right now looks for the lowest noise across the whole spectrum. What we want is to have the lowest bin noise bin from every, I don't know, 10, 20, 30 kilohertz. I don't know how the ENAM system, how they divide up the frequency ranges. I know that they use the red pitaya, and they have some, I think they do 1 megahertz captures at a time, and then they look inside, the software looks for the lowest noise bins. We have all that information available. So I think it would be pretty easy for me to, in the same way that I enhanced Whisper Demon to support grape reporting, I could enhance Whisper Demon to support ENAM's reporting as well. But I think, I mean, it may be possible that they would accept data from some other antenna other than the one they're using. But my suspicion is, perhaps maybe a prejudice about Germans, is they probably would prefer, almost insist that we use the same antenna as they do, since it would set the efficiency and of the overall system and the sensitivity of the overall system. So, so I know that one of the contributors to our to HamSCI, occasional contributor, is Carl. K9AL or something. He's in Indiana, and I believe he mentioned in one of the Whisper Demon groups that I was in, he was there, and he mentioned that he had one of those ENAM systems running. So I was hoping that we might, somehow we might be able to borrow one from somebody, Carl or somebody else, if they aren't using them. I'm going to pursue that and see if we couldn't set it up at Michael's as a way to, compare it against the other antennas that we were considering. So that's in terms of HamSCI, that's my area of focus right now is helping obtain the antenna systems that Michael has been investing his time. Thank you, Michael, for working on deploying those antennas. So anyway, that's my report. If you guys have any questions?
Remind
Oh.
me, which is the DX engineering antenna?
It's a monopole, active monopole.
which
It's
model?
a high. Michael, do you have it? It's.
Hang on a second. I'll
I
tell
can look
you.
for it. I can look
Is
for
this
it.
the one that has a 8.5 foot whip?
Yes, it has a whip, and
It's the model number is DXE Fox Victor I-1. Sorry, that's the voltage feed line. Sorry. But the engine, the antenna itself is DXE RSEAV-1.
Right. Okay, that's what I thought.
Yeah.
Yeah, that has a much longer whip than the German standard antenna. That one uses a 1 meter whip.
Yes. Yeah.
So that'll be a sensitivity difference.
That's, of course, sensitivity isn't as important as as maintaining a signal noise ratio. And that was one of my areas of question is how can you have a 1 meter antenna that's that's sensitive enough that you're above 10 megahertz and higher frequencies that the noise of the active antenna, the active componentry doesn't dominate. So I have to, I need, that's a question for Michael, but I'm, it's a reference antenna. It may not be the best, and even he says it's maybe not necessarily the best receive antenna, but it is a reference antenna. So,
right.
What do we want to get? Is there a possibility of getting both? Something that's a good receive antenna and a and that we could calibrate so that that they would accept our data. So
yeah,
I'm sharing. This is the LXQ. Are you seeing this screen?
yes, we are.
This is the LX1AQ amplifier with a pipe about 3.5, 4 feet in diameter in the shape of a hexagon. Receiving here at my site, and this is the DX engineering antenna.
Click up there at 28 megahertz where the band's closed. Yeah, or 29 megahertz up there. Okay. Now look at the and click. Yeah, you're an AM band. So you've got a minus 103.
Right.
In 10 megahertz. I mean 10 kilohertz bandwidth. So that's you subtract, that you got minus 143, subtract 40 from it, you're minus 143. That's 10 dB above the internal noise of the Kiwi. So whatever is going on there, the noise level is not determined by the Kiwi. It's being determined by the ionosphere or the amplifier. Now, if you go over to the LZ1AQ and look at the same frequency, roughly some quiet spot there. It's
Yeah.
no.
So
So there you see you're at minus 110 and you're narrow. So you change the AMN to AM. So your comparisons, it's up. There's a button up above. Yeah, that's that one. Okay. So now you're making a comparison. So you're 7 dB there above the noise. And again, we don't really know whether that's noise from the amplifier or from the ionosphere. It doesn't. It's likely it's the amplifier. So, because I think 10 meters is closed. Although I don't know where those CV
Well,
signals come from, and that signal right there, the 27 megahertz is leakage from the
that's
RX AAA.
leakage from the
Yeah,
888.
yeah. So you ignore that. That's one of the problems with the 888. If you it leaks 27 megahertz.
It's
So
fair. It looks like it's fairly quiet. If you can see my mouse cursor scrolling back and forth down here between 5 and 2.5, there's this fuzziness, and it also exists here, although to a lesser extent, interestingly. I think that's local noise, and I'm still trying to track that down. But
this
anyway,
is a loop on the ground.
this is not a loop as it is right now. This is upright.
Oh.
And I tried to turn it around so that I could minimize the magnitude of this.
Mm-hmm.
Put it broadside to whatever the source of noise was locally. This is 100 feet away from my shack, just standing out in the field. So not doing too badly.
Yeah, no, that's pretty good looking.
So we're
Yeah.
looking at horizontal versus vertical antennas here. And
No, unfortunately not. This is not horizontal. It's a loop, but it's oriented vertically at the moment.
Yeah, what we're looking at is the difference between an E field and a
right
magnetic field
and
loop
a
antenna.
magnetic field.
Right.
So what we're looking
Now,
at the moment, that waterfall is the magnetic loop, and this is the whip.
Now, one thing
monopole.
we need to be careful of is the actual galactic noise, which the loop technically will pick up more of than the E field, because the vertical whip has a null vertical, whereas the loop has a null that's in the horizontal plane.
Yeah, I tried to point it at the galaxy, so you know that.
Yeah, well, I'm interested in actually picking up the galactic noise, so
I'm not that strong, so. But I
but
think
yeah, they're definitely
but you bring up an interesting.
Not quite apples and apples.
Agreed. And so you bring up a point which is critical in my mind, at any rate, is now that I have these two instruments deployed here, what I would like to do is make some decisions about how to actually finally deploy them, and then what sequence of variations I should run them through to make the kind of comparisons, so apples to apples comparisons, to try to make it as much as possible apples to apples, so that we can make a recommendation, at least between these two. I have what I'm using, David, is I actually sent a message to that guy in Maine who is making these LZ1AQ knockoffs, and he sent me one. Or I bought one from him.
Yeah, the one I got was not.
Well,
from
it's the
Maine.
one that I may have the wrong state, but
okay,
the
N4,
whoever the guy was.
N4CY.
Yes.
Yes. Okay. Yeah,
I
that's
have
the
that.
one I have
have
gotten to.
The original Bulgarian design is on the way.
Right.
I'm hopeful it'll arrive relatively soon, and so I can figure out a way to deploy that. But the question still remains whether to use some version of the ENAM's antenna, if not the exact design, if we can figure out a way to construct it.
I looked at that, and the preamp is quite standard. The whip is a standard 1 meter, which is quite common. It's not that unusual a device. They use basically a J310 as the front end, which I think the DX Engineering also does. Just about everything does, unless you go into the really esoteric parts. And then their preamp, they have not even a 3 dB, 10 dB gain. It's an 8.5 dB gain after the input follower, just enough to overcome receiver noise. They use a
It's not
particularly
quite. It's not
heavy
really
op
quite
amp, but
not quite enough to overcome the 888's input noise. Its noise figure is,
essentially not right.
yeah. It's
But the idea is to have enough gain that your receiver noise is being masked
Yeah.
from a normal sensitivity receiver, shall we say?
Well, the noise figure on the 888 is almost 20 dB, and the Kiwi that we're looking at has a 15 dB noise figure, so it's 5 dB better than the 888.
Yeah.
But we don't have the nice spectrum of display on the 888 to look at these things, whereas on the Kiwi, it's, you got calibrated noise levels in the S meter next to the X meter. So it's calibrated reference to the input. Of course, the SMA connector is not, there's no knowledge of it, but of the antenna itself. But generally, I like in when I was showing you at the TCI 530 system feeding that Kiwi that I showed you, has about 10 dB between the TCI 530's feed and feed line and the input to the Kiwi, and it has about another 7 or 8 dB beyond that. In addition, more like 15 dB of gain between the TCI 530 and the input to the 888. So you absolutely need an LNA, whether it's in the active antenna as part of the design or something in the shack. But you're not going to see noise at above 10 megahertz unless you have some gain ahead of these wideband SDRs. So anyway, that's so. And but both of those, Michael, did you turn the gain up on the DX Engineering? You could, you had 3 gain settings.
I did. I set it
yeah.
up to the highest gain. I set it up
good,
to
because
plus 6 dB.
Yeah, it doesn't look like it's the Kiwi is far from overloading, so you might as well.
Yeah. And
So
what did you notice for what changed when you went from the -6 to +6? Other than signal strength, did it change the noise level?
No, not too much. Not that I can appreciate. It's a moderately noisy antenna just as is.
Right.
I couldn't get the noise floor below about 100 dB, 106, between 110 and 100 dB, and it remained about
where
the
you
same.
want it. That's where you want it, though. You want to find a quiet spot up near 30 megahertz, and you want your receiver to the Kiwi to show you something like 105, minus 105 to 110 in an AM.
And that's where we're at.
And that looks like where you're at. So that looks to me like you have the appropriate gain structure for the for that DX Engineering. Of course, the test is always go back and unplug the feed, make sure that the noise really is coming from the antenna feed line. It's hard can't really short the terminals of a DX Engineering. That doesn't help too
Yes, you
much.
can actually.
So
on the front of the box, there are 2 wing nuts. And those are the 2 terminals. One goes to the ground rod and one goes to the antenna. And you can put a jumper right across them. It's not exactly the same as what you get with a balanced antenna, but
that's right. What remains when you do that is the noise introduced by the ground loop. It's inevitable for an unbalanced antenna like that
Mhm.
E field probe. So that Glenn N6GN is working on his dipole and showed us today that with his active dipole, he's able to get I think 50 dB of common mode rejection at 30 megahertz. It was mind-boggling to see. I mean, he put the he put the short across the active dipole. It's an active vertical dipole with total length is about 5 meters of total vertical length, and he was able to demonstrate that every signal all the way across the band dropped by 30 dB or more. I think so. That's the advantage of a balanced antenna is you can that even if you don't have common mode rejection problems with a balanced antenna, you can verify that you don't have ingress of noise from ground loops. With an unbalanced antenna, there's no way to prove that. But it looks like it's pretty clean. And sure, if you short that terminals on the DX engineering and everything drops, then maybe you're not seeing anything from you can or put in you have a T11 probably on, don't you, on that feed line? You have a
Yes, on the
so
feed line, I'm
so so that
interposing a T11.
so that will help. That will help you. Uh, uh, eliminate common mode rejection that's inevitable on unbalanced antennas. So
Yeah, the three things in line are the T11, medium wave notch filter, and the Paul Elliott's shelving filter.
yeah,
So
yeah.
they're identical on both antennas. So
Well, those are good looking. Those to me, those are pretty good looking spectrum. And
so we
these
can
yeah.
now
And
that
these
is not, I don't know, that isn't a standard or sort of widely, I don't know what the production capacity is of the fella who made that the loop, the low impedance LZ1AQ. I think if we said, oh, look, we want 30 of them, maybe he would make them. What do you think, David? I think
Yeah,
what
I'm not sure. It's a good
what
question.
what's the what are you reporting the loop as? LN? Is that what it's
that
a
it
slash LN?
no, the individual who made this, let me see if I can get his call sign.
Well,
Uh,
I'm just looking.
he's looking at which receiver.
Yeah. What receiver? How are you reporting these receivers? Here's
Oh,
all of
sorry,
this is top spotters. I'm comparing
so
all.
B1 is the loop.
Okay. Well, you see, that's
FB
a
Foxtrot Baker is the DX engineering.
well. I think the DX engineering in terms
Is
of whisper
outperforming it.
reporting is is significantly better than the loop. I mean,
Yes.
that's quantifies
That-
the difference. There's just I don't think there's one band at which they're doing now. Our goal is not only to have whisper reporting. We're using it as a proxy for the sensitivity of the overall system to so our prime science goal, which is recording WWV. So it's not
Well,
it's not the only criteria, but I think this big a difference suggests that the DX engineering is doing a pretty decent
now,
job.
again, which antennas, which, Michael?
The Foxtrot Baker
Right.
is the DX engineering whip,
Okay.
and the B1 Bravo 1
B1.
is the LZ1AQ loop.
Oh, okay. What's
And that's been running
B2?
for about 24. B2 is a three-legged 200-foot folded dipole, terminated folded
Ah,
dipole.
oh, okay. Interesting.
And LN is an inverted L.
Gotcha.
ND
Well,
is a piece of
Yeah.
crap antenna. I'm afraid I got to replace up in
Well,
North
you're gonna
Dakota.
I usually look at these. I sort by raw number of spots rather than the number of
Right.
uniques.
But you're gonna
Yeah.
need to, if we're gonna consider matching the German system, you're going to need to test that one too, and that's going to be
Of course,
considerably less
of course.
sensitivity.
Yeah.
Well, but anyway, that's why I say if we're going to consider it at all, we need to get hold
Yeah.
of one in
I
some
mean,
way.
theoretically,
Maybe-
that's going to be about 10 dB down from the DX engineering, just from the size of the whip.
In theory, well, that's would be my understanding too. But how can you I am perplexed by their design, to be honest with you. So I
Well,
think
what's
yeah,
perplexing?
that
What do you
they
mean
would be
perplexed?
trying to they would be trying to measure background noise level with an antenna that is
Oh.
that's so insensitive.
Right.
That's
Well,
what
it's
perplexes
as I
me.
say, it's a pretty standard E-field antenna.
Yeah.
But yeah, you can use bigger,
Yes,
longer whips for it.
but I do not understand how they could be making, research quality measurements, with an antenna where the antenna's amplifier, is the dominant source of noise at higher frequencies. So I don't, that's what I don't understand about their design, because those JT 310 FETs, they're reasonably quiet. If you dump a lot of current through them, they get
Mhm.
quieter. But they're I'm a little mystified. But the reason I would like to learn more about it is not that I think that they have a better antenna. If it's is to somehow be able to utilize their network, because I think recording the background noise levels the way they do would be a valuable contribution to to our research activities in the coming years. I mean, it's a deeper view into the in the ionosphere, a different view into the ionosphere than we get from looking at signal noise ratio from whisper spots and WWV. So I just think it would be very, very helpful. So to be able to add that measurement, I'm interested in in that. And they, they're working with the ITU, and this is apparently the ITU wants to see this measurement being made around the world, which is I think a wonderful thing. But I'm not sure that I don't understand how they could be using an antenna that is that insensitive. But now, in his discussion, David, he mentioned the fact that by raising the vertical element 1 meter above the ground plane, that increases the sensitivity of the system by 10 dB. That's my understanding of. I just scanned the
Yeah,
document.
I
I
saw that
didn't.
discussion.
I don't. I saw that discussion, and I was. I just in scanning his document. It's not a document. It's a presentation he gave to some meeting a couple of years ago. So I'm a little. I'm mystified about the sensitivity issue about the 1 meter dipole. I didn't see how they got around that, but. Michael's a very friendly person, and and a professor of RF engineering. So I think I don't want to dismiss his design and its a performance out of hand. I certainly know whole lot less than he does about this subject.
Yeah, well, as I say, it's a standard design. It's not unusual in any way.
Yeah. Well, but
I have one that's very similar that was made by Dressler. It's got a different way of doing the second stage amplification, but otherwise.
Yeah.
And in fact, I believe the DX Engineering probably has a very similar amplifier in it as well.
I think, I mean, FET source follower with a gain stage that can drive coax is what
I'm
you got.
interested to see what's in the actual LZ1AQ, because he has an E-field preamp built in there as an oh by the way.
Yeah.
Yes. Right. In case you want to do.
There's a schematic.
In case you want to do a
somewhere.
monopole, he has provision for both low impedance dipole or loop as well as as you say, oh, by the way, if you want to stick a monopole on this, there's a high impedance configuration.
Yeah, I'm interested to see how it performs.
Rob, you mentioned that there was more description about it in a schematic someplace. I posted some links there to that antenna, the German antenna, the LZ1AQ, I guess, which is part of the ENAMs.
No, the LZN1AQ is a different, is
That's
not part of
different.
being, it's not, yeah, that's,
ENAMS is the one that we're talking about. That's the German reference antenna.
And
yeah.
does it have a schematic someplace of the way
Yes.
they did it?
Yeah, I maybe if you're
The
not on the,
presentation that Rob just sent
well, I sent it
has
to
the
the antenna.
schematic.
I sent
Oh,
it
it's
to
sent
the
to the
antenna
antenna group, right?
So if you're not on the antenna group, you didn't receive that document.
No, I didn't get that.
Okay, so if you, I will, maybe I should resend it to the whole of HamSCI, and then everybody will get it. And
I'll post a link here in this, if it's out there someplace.
Yeah.
Yeah.
well, the issue that I had with his was his documentation is and the ENAM's website is all in German. The website you can translate, the browser will do the translation, but his presentation was a PDF. So Michael ran it. They have apparently the Germans have this problem all the time, and they've got a website where you go submit your PDF in German, and it comes back largely in English. It was the illustrations had annotations in them and it's still in German, but the presentation itself was was translated into English. So that was very helpful. It's a pretty exhaustive discussion.
Yeah. Rob, do you want to just post the PDF here so that Bob can grab it?
Sure. Well, let's see. Irina, well, can I drag it into the chat window? You want to, or we want to scroll through it?
Yeah, somehow I forget exactly how you do it, but yeah.
Here, they see what happens if yes, here it comes. Let's see. Hold on a second. To everyone here. Type a message here. If I drag this in, no, I don't think so. I don't think
There
it's.
is a,
Yeah. Let me.
I've definitely done it. I forget how
Yeah.
you.
It didn't. Let me just. Unless it's 3 megabytes, so it may be that the Zoom doesn't want to have files that large, and
No, I'm forgetting, but there is a way to.
Well, I'm
add
looking in
a
the
file.
okay. I'll just send this thing that I sent to the antenna group. I'll just send it to all of HamSCI so that people can look at it.
Now, I don't
But-
know if you should do that because that might mean that they think that that's the antenna that you're blessing, the whole group.
Yeah, yeah, that's okay. Well, maybe Bob, I should just send it to you since you're the one who's expressed
Yeah, I'd
it.
like to see it if it's a simple
I-
schematic.
Go
it's
ahead
not
and-
very complicated.
Well, you have to
Send it to
scroll down through it. Nothing magic about their schematic though.
Well, the other thing is, well, I don't remember if non-members of the group can see the files in the chat if you just go on to groups.io, but
Yeah,
maybe
Well,
you have to
invite
be a
him.
member.
Invite Bob to the group.
yeah, you're welcome to you're welcome to the group, Bob. Just we're not posting that much to the.
He's not
the
that
antenna
bad a
group.
guy or anything.
Okay, that'd be fine.
We could
Well,
tolerate
just
him.
find the HamSCI antenna group on groups.io
Yeah, it's groups.io
and subscribe to it.
Then I can look in the history and get the thing. Yeah.
Correct.
yeah. So
All right. I'll do that.
anyway, so yeah, I think my point is ideally we have both. The best of both worlds would be a really good antenna. It's more it's truly sensitive. And I was going to look at, Glenn has been showing us, he's not ready to share it with the world yet, but he has this, his antenna design, which is the one I described with the great common mode rejection. And it really is sensitive down to the noise floor at 10 meters. And he has the whole, he's designing the mechanical parts. You put the active, I thought that the problem would be mechanical, that if you have to, you stick a vertical dipole, then how do you get the feed line? Doesn't have to go out, horizontally for quite some way if you're going to maintain common mode rejection. And the surprise that I got from it is you don't have to go that far. If you go 50 wire diameters away, you don't really have you don't have any interaction. So he's designed little standoffs that and he says you have to have the antenna itself. You need to use like number 28 wire, really fine wire, for the antenna. But with a very fine wire, you can space the feed line going down from the middle, space it maybe a couple inches away from the mast, and there's no influence, no loss of common mode symmetry. So that's one of the things that surprised me about his design. And it's apparently he has found this RV fiberglass pole that you can buy for $40 that is self-supporting, and he's in Colorado. So, he's in Fort Collins, so they get serious winds there. So he's got a design that he has an auger that you can screw in by hand, screw into the, some most ground, if there's any, unless it's hard as concrete, you can screw this thing in and you can plant the fiberglass pole and you have a self-supporting antenna that's no guy wires. It is 23 feet tall, or 24 feet tall, but he's in a homeowners association and he painted the whole thing painted the whole thing. And he says none of his neighbors has come by to complain about seeing the antenna. So he keeps saying he's 6 months away from having the whole design ready for the public. But since I've worked with him all the time, I may be able to get some instance of it out and get one to Michael to consider in time. And the whole thing is orderable from JLPCB. So the manufacturing issue, at least the fabrication of the antenna components, would be done entirely by JLPCB. So I think there's reason to consider it. It's cement, vertical dipoles are wonderful antennas if you can get them to work properly and deal with it. But I don't know when we'll get one. Speaking of things of projects of Glenn's, I have maybe on my doorstep 5 of his field probes, which is his design, the precursor or the first stage in this process to he's going to the vertical dipole for production. But so I'm hoping that I can turn my attention to the field probe. And I think, David, you've expressed one I would go to Michael. I'm, of course, going to keep one. And I don't remember who else might have expressed interest in one. But I think I get 5 of them for $250. So they're, that's $50 each. Plus, of course, you have to have a nano SA, a spectrum analyzer to connect it to. But anyway, that will be the next thing I work on this week, is verifying. Hopefully it comes in. I've never done this before. Hopefully it comes in and functions. If it doesn't, then it's all Glenn's fault, because he's the one who's trying to get people to not get him involved and just go order from JLPCB. Well, Glenn, let's see how well it works. So anyway, that's anything else that
I'm gonna sign off, everybody. Peace.
Yeah.
I'm gonna go to bed. I've been working all day.
Yeah, it's okay. Well,
So.
thank you. It's
I am expecting to get one of those Bulgarian, the original issues, and so I've got another loop to deploy for that. And then
Okay.
I mentioned I'm getting a Web 888. The main purpose of which is to show the spectrum. And so I may be able to actually have a third, spectrum display, which is
Yeah.
of Kiwi quality, and then get the field probe so I can make sure I'm getting as low noise as possible around here. So,
Michael,
all
what
right.
does yours show for status? The one coming from Bulgaria. Mine says it's gotten through customs.
I'm more. I think the China Web 888 is going to get here first.
Well,
So
the China AliExpress, they have that mechanism. They bulk ship stuff over, and then they mail it to you from some warehouse here in the U.S.
Right.
well, I've been tracking that. It's
Variant ones in for what
it was a minimal delay in customs. That
Yeah,
really
they don't.
went through customs fast. I've seen some people on the next gen SDR people complaining that customs was really holding up the Web 888s, but I'm expecting it tomorrow. It's at the local post office. So the Bulgarian thing, I'm not sure when it's going to come. We'll see.
Can I make a comment just before I cut out? I don't remember, I don't believe I mentioned it to this group, but I came across some announcements by Infineon last week that they were showing both the FX10 USB 3.2 V2 type developer stuff, and another one, an FX20, a 20 gigahertz one at a German, I can't remember what it is, a big German optics show, or I mean, video camera show last week. And that the developer kits for the FX5, 10, and 20 are apparently available if you're one of the truly anointed few. But finding out, anything from them about how to do that. I spent a lot of today trying to install their development tools that will be supporting this, the software stuff. And I got a message while we were chatting here from their tech support people. I don't know where they are. I figured it'd be the middle of the night in Germany. But anyhow, this stuff does appear to be moving towards availability, at least probably the FX5 and FX10s, which are the next generation. And the FX10 is the one we've been interested in. So I'll believe it when I see it, but there are hints that something is likely to happen. And they've said all along, they announced in November, I think, of last year, that they would be, the FX10s would be available in the fourth quarter of this year. And so it'll be just about that. If they, the distributors don't seem to have them yet. I was checking some of the distributors, or the development kits, but I keep hoping,
Dave, just before you leave, another topic. I'm sorry I just want to catch you before you leave. Yeah, I recall I had a orange pie, and did that end up with you or with you, Michael?
I have it.
You
I
have
have
it.
it.
Okay. Because
I
I
have
might want to get it back, or
Okay.
have you guys look at it if you're interested in it, because I think that with Linux Ubuntu 24.04, I think they changed the scheduler. It's a default scheduler in the kernel, and I'm wondering if that might help address that one problem. That's a really good candidate for for
I
deployments.
I think I saw that they did some of those, maybe Ubuntu did, were shipping the kernel that in question. I can't remember, it's 6.8 or I can't remember. I saw a couple weeks ago that had gone out in some of the distributions for similar boards. The I have a couple different three different variations of boards, two of the Orange Pi and another one. Um, uh, and there are some others. But some of the others like Armbian and stuff, I believe have the right kernels as well. Not
Yeah.
which ones.
So I
Well,
just made a USB stick to do an install of the 24.01 or 4,
Yeah.
whatever it is. So you're thinking
Mhm.
if you plug that into the Orange Pi, it may recognize it and take it and boot it and install it. Is that right?
Let's see. There's the Orange Pi. I forget its architecture. Does it?
For
Do you?
Armbian.
Yeah, I had tried Ambien, but this is over a year ago, and it looked like it worked just perfectly. But what I found was that if you're running Whisper Demon on it, that it would hiccup every 5 minutes. I mean, not exactly every 5 minutes. Every 3 to 5 minutes, there would be a little hiccup, and it would it would drop packets on the USB 3 bus.
Well, I think I'm gonna try this stick on it to see if it works. If it does, I may just send the thing to you after I've installed it.
Okay. Well, yeah. Well, if it was very specific to the 888, which is so demanding of the USB interface, hardware and drivers. And I got to the stage where I could not figure out. I pulled out everything I knew how to pull out that might be, I couldn't. What was strange was it was like a 5 minute cadence, and I couldn't see any log rotate operations or anything that would happen down a 5 minutes cadence. So that's when I gave up on it. Now, so I thought I'll wait till there's a new kernel and environment to see if it may not be in the kernel. It could be some service that's installed. It was a difficult it was beyond my ability to debug it.
Well, those kernels, those kernels did not start appearing in distributions. And I don't know about Ubuntu, but I don't remember, but they did not, the ones you're interested in did not start appearing until about 2.5 or 3 months ago. So, but they did start shipping in some of these.
Well, Bobby, give it a try. Put Ubuntu on it and plug a 888 in, and
Yeah.
Well, I'm
we
gonna
can.
put Ubuntu on the Orange Pi and then send you the Orange Pi with it on it.
Okay. Oh, thank you.
Now, Dave, let me go back to your FX10 thing. What I like, the idea I like is the FX type boards that you can buy for like $35 that take a standard fiber input, and they support several different protocols. And I was out there looking and I found a Verilog model on GitHub that somebody has written that supports that. So if we could get that model and port it to the FPGA chip that the people have been working with, Tom and whoever else, and then tie in the A to D converter you want to use, and that would generate the combination that you need for the high-speed interface, I feel.
Yeah.
Now,
Not
maybe this chip that you're talking about from Infineon is a new input to what you might put on a PC board with the A to D on it.
Yeah. Tom McDermott's given a lot of thought to the very specific needs that we might, the things that he thinks need to be there. But yeah, I do have that older board that has an older Altera or something CPLD, one of the examples, one of the uses that proposed uses for this was programming FPGAs. And it is still for the newer ones as well. Everybody always wants a faster programmer for development. And so I think there's some I'd be interested to know what exactly you saw. Bob.
I'll try to scrounge it up and send it to you.
Sure. Sure.
Does USB 3, Dave, as it's currently configured on a B-Link, for instance, that we're using for a lot of these HamSCI distributions, is that going to support an FX5 or 10 or 20?
It'll do the 5 for sure. The 10, I'm not at all. I'm not certain that at least the one that I have, I believe is 3.2 V1 or something, and so probably does not support it, but it depends, on exactly which one you.
There's a USB-C port on the front of my B-Link, which is, I think, claimed to be a 10 gigabit per second. Now, what protocol that is,
Well, if it claims to be 10 gigabit per second, then that's good. But if it's but just because it's USB-C and just because it's because that can be 2.0 as far as that goes.
yeah.
But if it's not a given, and it depends on which, the one I have, the B-Link I have, which I like a lot, I don't believe has the fastest. I was a little disappointed in the speed of that stuff when I bought it, but I have some other things like these Latte Panda Sigmas that have Thunderbolt 3 level support, or 3 or 4, and that's plenty fast. I don't know. Some of it may come down to the drivers too. And are you using Intel ones or using Ryzen ones?
Right.
Well,
These
I
are
just had
Ryzen,
in
yeah.
mind the fact that, Rob has been recommending the 5560 Ryzen. And of course, there's 5800s and 5700s out there, but whether whether those computers would be compatible with an upgrade or a model that was employing an FX5 or 10. Hopefully they would be. But,
I
Well,
think the CPU speed in the background and handling it with the drivers is going to be key. You're going to choke these things pretty quick.
yeah. Well, AMD has had the drivers and even the silicon for a long time, but they had evidently had licensing problems for a while until the last year or so. But even so, it's a jumbled mix, and you really have to look closely. I believe the B-Link I have does not say that it supports 10 gigabit on any of the ports, but I can't even remember. On the other hand, you can find a single board things that do. It depends on it's really a matter of the DMA and the scheduling and how much PCIe resources
Okay.
they 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 devoted to that.
I'm just looking at Amazon where the page for the 5560 B-Link, and it says 3 USB 3.2 Gen 2
Okay,
ports on it.
if that's true, that's good.
I think that two of them, and two of them are, that says, and if I zoom in on this, it's showing on the front panel two A-type slots, 3.2 Gen 2, 10 GPS, one Type C, 10 GPS,
That
and and it's something of something data and video. And then there's the back, they have a USB 2, and above it a USB 3.2 Gen 2 10 GPS. So it looks like it's the V-Link is
There's other protocols layered on top of that. It's a mess. They could very well be saying the 3.2 Gen 2
yeah.
is essentially the same as Thunderbolt 3, I think, but
Yeah.
that's the lowest level. Then they can layer on top of it, depending on the drivers and stuff, the video and a whole bunch of other stuff, much of which brings it into the USB 4 category. But they often don't do that because it costs a lot to get them certified.
Yeah.
So,
Well,
but
okay, well,
what you're saying sounds good.
it sounds encouraging, but as we all know, specs are easy to write.
Yes.
Hard to implement.
Even
But,
easier.
well, I don't know how easy I don't know how easy they are to write, but that's a painful process.
Yeah.
Okay. But anyway, it's a
That-
I think the
I'm
B
going
links
to
at
bed.
least yeah. Bye, Michael. I think the 5560 looks like it should support future USB
I
speeds.
probably have ways to test it, but
Yeah.
I
Okay.
see y'all. I'm going to.
Okay. Okay. Take care, Bob. Okay. I think we've maybe exhausted the group here.
that's it for me.
Yeah, okay. You do anything on K9Q? Oh, you're gone. Okay. Okay. Well, then I will back out, I guess. Take care, everyone. Till Thursday or next week. Huh? Unless anyone has a question for me, but I think everybody's gone. So,
I think we're all teched out.
okay. David, as I recall, you were interested in one of these field probes.
Yes, absolutely.
Okay.
Thank you.
Okay. Okay. Well, let's see if I'll go out and see if it arrived. DHL. Okay. Take care.
Yep.
Take care,
And
everyone.
Kamal,
Bye.
just send me an email. $73. I'll talk to you later.